Hello friends, welcome back to another session of mechanical engineering fundamentals under internal combustion engines. So in the last class we have seen the classification of engines, spark ignition and combustion ignition engines, the broad classification of reciprocating engines. So today we are going to discuss in detail the spark ignition engines and the ideal cycle for spark ignition engines, that is Otto cycle. So all of you have seen the automobiles running on road, right? Starting from the motorcycles, then the light motor vehicles like cars, jeeps, heavy vehicles. So all these are powered with some form of prime movers or engines fueled by fossil fuels most commonly, right? So what is the mechanism behind that conversion of the chemical energy contained in the fuel? How is it converted to the mechanical power which propels the vehicles? For that you need to understand some basics of thermodynamics. I hope all of you have the knowledge of thermodynamics first. You might have studied already, like what a system is, the properties, process and cycle. So a cycle, in simple words, it is a series of processes such that the initial and final state of the system are the same. In almost all the cycles are having four different processes which forms the closed loop. Okay, so let us move on to the first air standard cycle, the ideal cycle for spark ignition engines, that is Otto cycle. Please listen till the end and revert if you have any doubts. Please don't forget to subscribe to get the notifications of the future videos, and again share to the friends if you find it interesting. Okay, so Otto cycle, the ideal cycle for spark ignition engines. So you can see the Nicolaus August Otto here. He is the one behind the revolution of spark ignition engines and the cycle behind that. So Nicolaus August Otto, the inventor of the four-stroke Otto cycle, was born 14th June 1831 in Germany. So he began his first experiments in 1862 with four-stroke engines. So I'll show you the first four-stroke engine of him. So they corresponds to the today's engines. So this was his first engine, and the corresponding actual cycle, actual Otto cycle, is also shown here. This was his first four-stroke engine he developed based on his cycle, Otto cycle. So these are the four different processes in the Otto cycle, namely isentropic compression, that is reversible and adiabatic compression. Okay, the volume will be decreased. Constant volume heat addition, the volume is kept constant and heat is added in the form of spark plug. A spark will be produced from the spark plug in the spark ignition engines. That's why the name spark ignition. The ignition is begun with a spark produced by a spark plug. Third process is the isentropic expansion, again reversible and adiabatic expansion, volume increase. Then finally the constant volume heat rejection. Whatever heat is generated as a result of the combustion will be rejected to the atmosphere through proper channels. So there are four processes, two constant volume. It is also known as isochoric. Constant volume process is also known as isochoric process. So there are two constant volume process and two isentropic process. What do you mean by isentropic process? That is, entropy remains constant. Similar to isochoric. Isochoric means constant volume. So isentropic means entropy constant. So an isentropic process is a reversible process, obviously, as well as adiabatic. There is no heat transfer between the system and the surroundings. Adiabatic means there is no heat transfer. So reversible as well as adiabatic. So here you can see the ideal and actual cycle. This is the ideal cycle on a PV diagram, pressure volume diagram, and here you can see the actual cycle comprising different strokes. Different strokes are also shown here. Okay, so let us discuss on this for a few moments. Okay, so don't confuse the processes with the stroke. First of all, please remember that don't confuse these processes in a cycle with the strokes. Okay, strokes are different. Strokes are just the movement of the piston between the dead centers. In the last class we have seen the dead centers, top and bottom dead centers, right? So the processes are purely thermodynamic process. So let us begin with this Otto cycle. So let us forget these strokes now. Okay, the strokes I will explain in the coming slides with animation. Okay, so let us see the ideal Otto cycle first. Okay, there are four processes as we have seen from the previous slide. There are two isentropic process and two isochoric or constant volume process. In the constant volume process, heat is added and rejected, and isentropic process, the volume is decreased when the piston is moving from bottom dead center to top dead center. That is corresponding to this first diagram. The piston is moving from bottom dead center to top dead center. That is, the volume will be changing from maximum volume to clearance volume. Maximum volume to minimum volume, 1 to 2. That is isentropic compression of the air. Isentropic compression of the air fuel mixture. In the case of spark ignition engine, it is air fuel mixture. Okay, so in the case of ideal cycle, we are considering the working fluid as air. Since it being a air standard cycle, we are considering air as the working fluid instead of air fuel mixture. But in actual case, it is the air fuel mixture. Right? There is a difference. That's why this is shown differently here. Here it is air fuel mixture. That is actual case. Ideally, we are considering the working fluid as air alone. And 2 to 3 is the heat addition in the form of spark. You can see the spark plug here. In the actual engine, you can see the spark plug and the valves, inlet and exhaust valves. So here, this being an ideal cycle thermodynamic, to show the thermodynamic process, air is the working medium and heat is added. Heat is added here by removing the insulation. So here this pink color represents to show the process is adiabatic. There is no heat transfer, completely insulated. The cylinder is completely insulated. So this is the process 2 to 3, constant volume heat addition. Actually, it is taking place in the form of spark from a spark plug by creating a heavy voltage difference between the endpoints. And the third process being again the isentropic expansion. The piston moves from top dead center to bottom dead center. The volume increases from 3 to 4, V3 to V4. In actual diagram, it is the power stroke. In actual, it is the power stroke. Here you can see the power stroke. Then the fourth process is heat rejection, when the piston remains at the bottom dead center. The piston remains at the bottom dead center and the heat will be rejected. Fine. So this is the ideal Otto cycle for different process: two isentropic process, compression and expansion, and constant volume, heat addition and rejection. So you can see the relative magnitude of the length of these curves or lines here. The heat rejection is less and heat addition is more. That means more heat is added, less heat is rejected. The difference between these two, Q in and Q out, these lines, is converted to power, net work output. This is very simple. So you should understand while drawing this diagram also, it is very simple to understand, but most often the students used to commit mistake while drawing this. And also you can see that these isentropic processes are not parallel to each other. Right? On a PV diagram, two isentropic lines are not parallel to each other. It is purely dependent on the initial and end state. Okay, we are assuming the entropy remains constant, but entropy ideally only we can assume it remains constant. There could be some form of heat transfer which will increase the entropy. So now coming to the actual cycle. Yeah, the four processes, you know there are four processes. The first one is intake stroke. Okay, this is the intake stroke when the piston moves from top dead center to bottom dead center. Then the compression stroke, piston moves back from bottom to top. Fine. Then the third stroke is expansion stroke. So you can see here intake, which is usually taking place at a pressure less than the atmospheric pressure. Then only we can take in the air fuel mixture from outside into the engine through the manifold. Then second is compression stroke, it is shown here, and the third process is expansion stroke. So here, since this is the heat addition is taking place at a constant volume when the piston remains at the top dead center, that is not a stroke. I hope you understood. Only the movement of the piston between two dead center, for example from bottom dead center to top dead center, that is known as compression stroke, and the reverse is expansion stroke. Okay, so whenever the piston remains at a particular position, the heat addition and rejection take place. So that those are not considered as strokes. Okay, so now the power will be obtained when the expansion, isentropic expansion takes place. Then the fourth stroke is the exhaust stroke. The piston moves upward, that is from BDC to TDC, and pushes out the combustion products through the exhaust gas. Through the exhaust valve, the combustion products or exhaust gases are pushed out by the movement of the piston from bottom dead center to top dead center. So these are the four processes, and for strokes, the difference between the process and stroke. If it is not clear, please tell me. I can explain you further in more elaborative way in another session. So don't worry about that. Please go through this. If you have understood, it's okay. If you are not understood, please let me know so that we can elaborate on further. Okay. So these are the different parts in particular to the petrol engine. The common parts are two valves, inlet and exhaust valve, combustion chamber, piston, connecting rod, crankshaft, then the sump. All these are common. And the specific one, the part which is only there in the petrol engine, spark ignition engine, is the spark plug, which is to start the ignition, to create a spark in the combustion chamber at the end of compression stroke. At the end of compression stroke, you need to ignite the mixture, air fuel mixture taken in during the intake stroke and compressed during the compression stroke. So in order to start the ignition, you need to produce a very high voltage spark. For that, we are using a spark plug in a spark ignition engine. Now let us see that 4 strokes in detail, how the position of the piston is, how it is moving, all these things we will discuss in detail. Intake stroke. Okay. So this is the intake stroke, this line, the bottommost line in the actual PV cycle, PV diagram. Okay. The piston moves from top dead center to bottom dead center, and the inlet valve is in the open position. Exhaust valve remains closed. There is no spark is being produced by the spark plug. The piston moves from top dead center to bottom dead center. So the pressure will drop. It will be vacuum pressure. That means below the atmospheric pressure. When the pressure is below the atmospheric pressure, that pressure is termed as vacuum pressure. The intake valve is opened. As a result of that, because of the low pressure, the air fuel mixture is sucked or taken into the combustion chamber or the cylinder. The portion above the piston is usually termed as combustion chamber. So the inlet valve will be opened as a result of the vacuum pressure created, and the inlet valve will be opened and air fuel mixture will be taken in during the intake stroke. Second one is compression stroke. So the piston again moves from bottom dead center to top dead center. It is shown here, this line. This is the compression stroke. The piston again makes a move. Both the valves remain closed. Inlet as well as exhaust valves remain closed. The piston moves from bottom to top dead center and compresses the air fuel mixture which was taken in during the previous stroke, intake stroke, and the pressure and temperature of the air fuel mixture reaches its maximum. Then at the end of combustion strokes, heat is added. This is not a stroke, this is a process. Okay, this is not a stroke. Heat addition is taking place in the form of spark plug, a spark from the spark plug. At the end of combustion stroke, the piston remains in the top dead center position. So as a result of the spark created by the spark plug, what will happen? The burning of the air fuel, compressed air fuel mixture takes place. The gas mixture starts expanding. The mixture burns very rapidly, and expanding gas creates a very high pressure against the top of the piston. So piston should move downwards. Piston should move downwards. There is no other way because both the valves are closed. So in order to take care of the increasing volume expansion, the piston will move. Makes the expansion, or otherwise known as power stroke. Since we are getting the power output during this stroke, it is known as power stroke. So in always, whenever there is an expansion in a piston cylinder device, we are getting power output. Whenever there is a compression in a reciprocating system, that is when the working fluid is compressed in a piston cylinder device, we need to give in some work. Whenever expansion is taking place, we can take out the work. So during expansion or power stroke, both the valves remain closed. There is no spark being produced. Piston moves from top dead center to bottom dead center, producing the power output, work output. So this is the expansion or power stroke. The force drives the piston downward to the crankshaft. The valves are closed. The volume is increased. No more energy is added, and because of this, the internal energy of the gas is decreased because we are getting power output, and the temperature also will be decreasing. And the final stroke is exhaust stroke. That is the fourth stroke in a spark ignition engine. The exhaust valve is opened. The exhaust valve is opened. The piston moves from bottom dead center to top dead center. You can see here this line. It is taking place at constant pressure. Okay. And the volume changes from maximum volume to minimum volume. At the bottom dead center, the exhaust valve is opened and the piston moves up to the cylinder. The pressure drops to approximately the pressure outside the cylinder. Not the same as the intake stroke, but just above the atmospheric pressure. Then only we will be able to exhaust the combustion products from within the cylinder to the outside the cylinder. So exhaust gas leaves the cylinder and the volume is decreased. So these are the 4 strokes: intake, compression, expansion or power, and exhaust strokes of a spark ignition engine. So this is the animation. We can see the animation here. During the intake stroke, the inlet valve is opened, then compression stroke, spark, power stroke, and exhaust stroke. This is another way of animation. Here only air is coming and the fuel will be injected using an injector. In the modern vehicles, there is no carburetor directly. The fuel will be injected in the intake manifold. So valves will be operated using a rocker arm and a camshaft mechanism, as shown in here. You can see here. So depending only during the intake and exhaust stroke, the valve should be opened, right? So during the intake stroke, inlet valve, and during the exhaust stroke, the exhaust valve need to be opened. During the other strokes, other times, the valves should remain closed. So that is controlled by a camshaft and a rocker arm. In the coming class, we will discuss about the diesel cycle, the ideal cycle for a combustion ignition engine. Then afterwards, we will discuss about 2-stroke engines. Thank you for watching. So let us stop for today. We will continue in the coming session.